Good day everyone! Welcome to our lab activity on fluid flow in pipes. In this experiment, we are exploring the fascinating behaviors of fluid flow within pipes. Our goal is to observe and understand the distinct characteristics of fluid flow, and to identify the differences between laminar and turbulent flow regions. Our objective is to investigate how fluid behave within pipes under different conditions and to distinguish between smooth, steady laminar flow and chaotic, unpredictable turbulent flow. Let's start with defining what is a laminar flow. In this type of flow, the fluid moves in smooth parallel layers within or without mixing or minimal mixing within them. Laminar flow is typically observed at low Reynolds numbers. Next, we have turbulent flow. In turbulent condition, the fluid moves irregularly, forming swirling eddies and vortices. This flow pattern is common at high Reynolds number. So we just finished writing the necessary data, the weight, the mass, rather the dimensions of the apparatus that we made. So we are about to start. So as we start, we will be using a die so that we can possibly or easier for us to analyze or to distinguish the flow. So in Tagalog, in easier way to understand, so that ma-observe natin or mas makikita namin yung flow ng fluid. Okay? So now we are starting to fill a 200 ml of water, and we will record when the time will reach the 200 ml. So we just open the valve, so we let the water flow, and we will record the time when the water is 200 ml. By doing that, after recording the time and we know the volume of the water that flow, we can get the flow rate by dividing the volume divided by the time. Okay? So after observation, after gathering all the data at this apparatus, we are about to proceed in the next part, which is the getting of the terminal velocity. So there we will use a sphere or the jollen, and we will identify its terminal velocity by computing distance over time again. So we will drop it. At this part, we are just getting the data, the weight of the marble and everything. So there we will drop the marble, and we will calculate the time using a timer. So until when it will drop to the end, and of course we have the dimension how long it travel. After getting the necessary data, we will now use this formula in the screen, which is the formula for terminal velocity equals 1 over u, which is the viscosity, the liquid viscosity. Then the d there will be the diameter of the sphere. Then the ps is the density of the sphere. Then the pf is the density of the liquid. So using that, we will be solving for the viscosity of the liquid. So after getting the dynamic viscosity or the viscosity of our liquid, we will be able to use the formula of Reynolds number, which is equal to the fluid density times fluid velocity times the pipe diameter divided by the dynamic viscosity. So it is flashed in the screen at the left side. That would be the formula for RE. Now you will wonder where will be or where we will get the fluid velocity. That will come from the formula of the flow rate, which is flow rate equals to the volume over time, which is also equals to the area, cross-sectional area times the velocity. So after getting the flow rate, we will equate it into the velocity times the area, and we'll just divide it by area to get the velocity. So we will be solving for the RE of the fluid, which will define the RE will define whether the fluid flow is turbulent or laminar. But in our case, in our experiment, we didn't able to get a value for turbulent flow because our RE is always low, so meaning there's no turbulent flow in our system, and we concluded that it is because of the pipe dimension, the apparatus itself, that we are not able to provide or execute a turbulent flow.